All right, so this is our notes on 3x3 systems, and we're going to kind of go through each of the four problems I have here to kind of go through how we come up with the solution. So a 3x3 obviously related to a 2x2 system, only there's three variables instead of two, which obviously makes it a little more complicated. But the process is the same. We still just want to eliminate variables. So here's my original problem right here. And what I like to do is I like to take the first and second equation and then the first and third equation and eliminate the same variable. It is important that each time you do this, you eliminate the same variable. So based on the first two equations, I think z is the easiest thing to eliminate. If I multiply everything across the top by 2, this top equation right here, I get 4x plus 6y minus 2z equals negative 14. And then here, I don't have to multiply anything because you already have a positive 2z down here. So here, it's 4x minus 2y plus 2z equals 14. Right? And now the negative 2z and positive 2z cancel, and I combine 4x and 4x is 8x, 6y negative 2y is a 4y, and negative 14 and 14 is 0. So we get 8x plus 4y equals 0. Now, since I've eliminated the z on the top two, I need to eliminate the z between the first and the third one. So 2x plus 3y minus z equals negative 7. And then that bottom one, x plus y minus 3z equals negative 10. When I go to eliminate the z here, I multiply everything through by negative 3. That way, that way when I multiply through by negative 3 here, I get a positive 3z, and then you're left with the negative 3z down here. So when I multiply through, I get negative 6x minus 9y plus 3z equals a positive 21. And then we can just recopy the bottom, x plus y minus 3z equals negative 10. The z's cancel, and I'm left with negative 5x, negative 8y equals 11. And now I have a system. 8x plus 4y equals 0, negative 5x minus 8y equals 11. And that's my system. Now here, I'm going to eliminate the y. And now we're just doing a basic system of equation. And we multiply everything through by 2. 16x plus 8y equals 0. You combine your like terms, you get 11x equals 11, and my x equals 1. I plug a x into one of my two systems of equations. 8 times 1 is 8, plus 4y equals 0. We subtract 8, we divide by 4, and my y equals negative 2. And then finally, to get my z, I have x is 1 and y is negative 2. I plug back into an original. I chose x plus y minus 3z equals negative 10. 1 plus negative 2 minus 3z equals negative 10. Negative 1 minus 3z equals negative 10. Negative 3z equals negative 9. And then my z equals 3. Let's try another one. I'm going to get rid of one of the variables. Here, between the first two equations, I choose to get rid of x. So what I'm going to do is I'm going to multiply the top equation by 2, and we leave the bottom one. So 2x plus 4y minus 10z equals 18. We multiply through by 2. Here, since I already have the negative 2x, I just leave it. Negative 2x plus y plus 3z equals negative 6. Combine our like terms. The x's cancel now. And we're left with 5y minus 7z equals 12. If I take my first and my third equation and put them together, the x's actually cancel immediately. 2y negative 3y is negative y. Negative 5z and 2z is negative 3z. And 9 and negative 7 equals 2. So now I have this equation here, and I have this equation right here. And that's the systems of equations. 5y minus 7z equals 12. And then negative y minus 3z equals 2. If I multiply the bottom equation by 5, 5y minus 7z equals 12. Negative 5y minus 15z equals 10. And I get, when I combine like terms, after the y's cancel, negative 22z equals 22, so our z equals negative 1. Go back to one of my two systems of equations. We'll do negative y minus 3z equals 2. Negative y minus a negative 3 times negative 1 equals 2, which is negative y plus 3 equals 2. We subtract 3. Negative y equals negative 1, and y equals 1. And now my y equals 1, my z equals -1, I plug in x plus 2 times 1 minus a -5 times -1 equals 9. X plus 2 plus 5 equals 9. X plus 7 equals 9. And my x equals 2. Answer 2, 1, -1. That's how you find the answers to a 3x3 systems of equations. Now there are two special cases. One is a no solution. If you notice here, I take the top two, and when I distribute the 3 excuse me, through here, I get -12x minus 6y minus 3z equals 45. Here we get 12x plus 6y plus 3z equals 45. When I cancel everything, I get 0 equals 90. If you ever end up with a false statement, that means you have a no solution. Here, when I eliminate the x's, or excuse me, I eliminate the z's, I distribute the top by -2, and I get -6x minus 10y plus 4z equals -26. And here we get -5x minus 2y minus 4z equals 20. And I know I didn't write it down, I'm not sure why, but it's a -11x minus 12y equals a -6. I actually moved it right down to here. Okay. Now when I do my first and my last one, I get 3x plus 5y minus 2z equals 13. And I get -14x minus 17y plus 2z equals -19. It goes right to canceling because the -2z and 2z cancel out. So now 5y and -17y, -12y. 3x and -14x is -11x. So you end up with -11x minus 12y, and the 13 and -19 is the -6. So I put these two one on top of the other. The equation that I moved from down here as well as the equation from right here. If you multiply the top by -1, you end up with an answer of 11x plus 12y equals 6. Everything cancels. So when everything cancels, you're left with 0 equals 0, which is an all reals answer. It basically means all real solutions will work.